Okay, using this question, I want to revise on water cycle types of question. So nowadays, water cycle is not your typical water cycle question. It's not so straightforward. It usually brings in applications of everyday life or anything that we see. But before that, I'm going to revise with you a typical water cycle. So in a typical water cycle, you have a body of water. So what will happen is that we have two processes driving water cycle. The two processes, the first one would be evaporation. The second one would be condensation. Now, evaporation involves heat gain, and condensation involves heat loss. So we'll look at how this plays out in a typical water cycle. So what happens is in nature, there is actually your sun. Your sun actually emits a lot of heat. So what happens is that your body of water would gain heat from the sun and it will start to evaporate. So when they evaporate, okay, they will actually go upwards. All right, now what do we have here after they evaporate is something known as water vapor. And the process that happens here is actually known as evaporation. Okay, so it is from liquid water to gaseous water vapor. So as it goes up, it starts to lose heat. So remember condensation, we're talking about losing heat. So where does this warmer water vapor lose heat? It loses heat to the cooler surrounding. So as it loses heat to the surrounding cooler air, it will start to condense into very, very tiny little water droplets. And this is actually what we see as clouds. Clouds are actually just tiny water droplets. Now, the misconception here is that a lot of students would think that clouds are actually water vapor. That's not correct. Clouds are actually water droplets. And the reason is because you can see them. You can literally see them. So the fact that you can see them tells me that it cannot be water vapor because water vapor is a gas. So at your level, you will not be able to see the gases that you are familiar with. For example, nitrogen, oxygen, carbon dioxide. These are colorless gas. But of course, when you go up to higher levels, there are certain gas that you can see, but we're not talking about that. So after that, how does it fall as rain? Okay, now when the water droplets start to gather together and form bigger water droplets, right? It becomes too heavy to suspend or float in the air, in very simple terms. They start to fall down as water droplets or as rain, okay? And then they go back to your water body. And this is called the water cycle because the cycle is continuous, all right? But the one thing that I want to caution all students is that this part here is actually liquid. This part here is also liquid. So a lot of students think that, this is actually gaseous. No, it's actually liquid. We're talking about tiny water droplets. All right, so the golden rule is that if you're able to see it, it cannot be water vapor. It has to be something else. In this case, will be water droplets. So now that we are clear with it, let's take a look at how an application question would require the water cycle. So, in this question, Kelly took up a tub of ice cream from the freezer and placed it on the table. White fumes were seen. So the fact that they are white fumes tells me that it cannot, no way can it be water vapor because I'm able to see it, okay, above the cold ice cream. After a while, the white fumes disappeared and she noticed that there was a thin layer of white solid on the surface of the tub. So once again, it cannot be water vapor, it has to be something else. So Let's take a look. The white fumes, given that they can be seen in the air, try to form some relationship between this and the water cycle. You will realize that, hey, the white fumes are like my white clouds. And yes, it's true. Now, how do we get these white fumes floating in the air? So there must be some warmer water vapor losing heat. Now, because this is a cold ice cream, all right, it cannot be the ice cream losing heat because the surrounding temperature would be of a higher temperature than the ice cream. So probably what happened was that the ice cream actually caused the surrounding air, okay, to actually lose heat to it and become cooler. So to indicate that the surrounding air is cooler, I'm going to draw a ring using blue color. Okay. Now, then the warmer water vapor that is in the surrounding would have then lost heat to the cooler region over here. So as it loses heat, it starts to condense into very tiny water droplets, okay, that appears to be my white fumes, just like the white clouds in the air. All right. So then after that, now I know that these white fumes are actually tiny water droplets. Now, the question then asked, explain why the white fumes disappear after a while. So we know that since it's water droplets, how do liquid water disappear? Just like a puddle of water, right? It disappears. The main idea is that it would actually evaporate. So the same idea is actually in place here. Okay, we're talking about evaporation. So with evaporation, we always talk about heat gain. Where is the heat being gained from? So in this case, you will need to understand that as it goes further out, okay, these tiny water droplets will gain heat from a warmer surrounding that is further out. So when it gains heat, it would evaporate. So how do we answer an evaporating question? We have to say that where is the heat source? The heat source would be the surrounding warmer air. All right, so you can say that the white fumes bracket tiny water droplets. This would help yourself to form a clearer idea. Gained heat from the warmer surrounding and evaporated. Alright, so when it evaporates, it disappears. Okay, so while we're on the topic of evaporation, I also want to take the opportunity to revise with you what are the factors affecting rate of evaporation. So factors affecting rate of evaporation, that would include, okay, so how I remember it is W-E-T, wet. Now, W stands for wind speed, E stands for exposed surface area, T stands for temperature. Now, we also need to realize that an increase in any of this will result in an increase in evaporation. That is one thing we need to understand. So therefore, any increase in this will affect your rate of evaporation. So if the question asks, oh, how to make the white fumes disappear faster, you would actually increase the speed of the heat, the surrounding temperature. Okay? So then after that, they were asked how the white solid was formed. So the fact that it was a solid tells us that it is actually ice. Why? Because in the in water, right, the state of water that is a solid is actually ice. So for ice to actually form, you first need water. And this water will need to lose heat in order to freeze. Right? Okay, so let's take a look at this question again. So when you think about it, where did the water come from? The water actually came from your warmer surroundings. So remember, you actually have some air that's surrounding it. So when it first got taken out of the freezer, this warmer air contains water vapor. This water vapor will touch the surface of your ice cream. And what will happen is that they would lose heat and condense into tiny water droplets. These tiny water droplets would then continue to lose even more heat. And what would happen is that this would cause them to freeze, right? To freeze and then become, I'm going to use gray color to represent the solid ice that we see on the surface of our ice cream. Okay, so we first need to talk about the surrounding warmer water vapor. So it's good to actually say warmer and cooler. Alright, now in water cycle question, right, it is a must to identify the cooler surface, because the cooler surface will tell you where your water droplets will form, where the condensation will happen. So in this case, the cooler surface is my tub of ice cream. Alright, so the warmer water vapor from the surrounding touched or came into contact cooler surface of the ice cream, lost heat and condensed into water droplets. These water droplets then lost heat to the ice cream and froze to ice. Okay, and that is how you answer a question on water.